you're going to want to swish and swallow, because the more contact you make with the inside of the mouth, the more that's also going to stay there, be absorbed, etc.
For it to be being pushed into the forefront now of the medicinal purposes of it was something that we've always known.
They call it a side effect or adverse effect. Depends on how you look at it.
It's Reefer Madness, the podcast, with Trevor and Kirk.
Kirk, we're back.
Hey, Trevor, how's it going?
It's going well. So I'm not going to ask permission to do a bunch of heavy science episode. I'm going to tell people they should be excited about the science. This is I admit, this is a science-heavy episode, and we're going to be talking about receptors and agonists and antagonists and modulators, and I know not necessarily everybody's cup of tea, but I think it's interesting and exciting to, hear the nitty-gritty of how the endocannabinoid system works.
Yeah, when I was listening to this interview with Dr. Laprairie, I kept thinking this is an episode of pharmacodynamics and pharmacokinetics, right? This is essentially the pharmacy behind how cannabis works in our body, right? This is like studying how any other medication affects the body. This is how cannabis gets into our cells and how it modulates itself.
Yes. This is a tiny slice of how CBD does its thing, literally at the receptor level, what CBD does to the CB1 receptor, and we go back and forth a lot. Is whole plant extract better? Is individual cannabinoid extract better? And I know there's really strong advocates on both sides, but I think it's important to, and we do at the end of this with Dr. Laprairie talk about, how they could use this research down the road. This is a down the road research thing to possibly create in the lab some cannabinoid or cannabinoid-like things that act like CBD at this particular receptor site. And I know that gets people excited, but I think what we're going to, when we eventually get that far, maybe I'll talk more at the end, I don't think the end of how cannabis is going to be used is going to be, it should be all whole plant or it should be all extract. I'm sure it's going to be a spectrum of, some individual things we pluck out of here are going to be important, and sometimes the whole plant's going to be important, and it's good to see both sides.
Yeah, for me, this is trying to figure out how to apply this episode to my practice, and that's what I was doing. I was trying, and so of course, after listening to your conversation, I went into his paper. His paper is extremely, what can I say? Dense.
Well, it is, and that's not bad. But people have to remember, it's not quite a right analogy, but I'm going to go with it anyway, because lots of people watch The Big Bang Theory. So in Big Bang Theory, we have the PhDs who are literally on the cutting edge of science trying to figure out how the world works. And then you have the engineers who take what the PhDs learned and try to apply it to a real world thing. That's kind of the difference between the PhD medical scientists and, the doctors, pharmacists, and nurses. Doctors, pharmacists, and nurses, we are not on the cutting edge of research. We have to rely on what the scientists find out and then try to figure out how to apply that to an individual patient. The PhDs, my dad happens to be a PhD, and he said before, a PhD, by the time you get your PhD, you know absolutely everything about absolutely nothing, which means you get sort of hyper-focused on one tiny little sliver of knowledge. You know a whole lot about that thing, but not necessarily not as much as you would like about everything else. And that's sort of how medical research goes too. The researchers, your average clinician has no idea, how to run the type of study Dr. Laprairie and his team did. But hopefully they can give us some pearls that we can apply to, a general patient.
Yeah, I think that's a great analogy. So we're just jumping right into this one, right?
Yeah, I think we'll jump right in, and at the end, if you want to go over some stuff like agonists, antagonists, that kind of thing, no problem. But I think, honestly, for a very dense I agree, not necessarily lay public-friendly paper. I think Dr. Laprairie does an excellent job of explaining what his team did, how they did, what they found, and then how it might apply out there in the real world. So let's listen to Dr. Robert Laprairie, and we'll come back at the end. So, Dr. Laprairie, we've got an interesting paper, and my apologies for our non-sciencey people. It's a bit of a sciencey technical dive, but I think people will get something out of this because we're spending a lot of time with CBD and how it does what it does. So we'll quickly do the title: determination of the negative allosteric binding of cannabidiol and CB1 receptor, combined computational site-directed mutagenesis study. So it is fine if you only understood 2 or 3 words of that title. We're going to go through a whole bunch of it, and Dr. Laprairie is going to help us make sense of what it means and what it does. So, Dr. Laprairie, as I sort of asked beforehand, my plan is we'll do a few definitions first. I'll sort of tell you what I think they mean. You jump in and tell me whether they're wrong, and then we'll kind of get into the paper.
Sounds good.
So let's start with real simple CB1 and CB2. These are 2 different receptors for cannabinoids in the body. My shorthand that I tell people is I generally think of CB1 as being the one more or less in the brain and spinal cord of the CNS. So that's kind of sort of where, for example, THC makes you feel high, and CB2 is kind of sort of the immune system. That's
great. Yep, that jives.
Okay. So THC and anandamide bind to both CB1 and CB2, and we'll talk about THC quite a bit here.
Yep.
So this gets into what's an agonist, an antagonist, and a partial agonist. So we'll quickly go through this. So people have heard me talk before about lock and key. So the example I use for lock and key is insulin. It goes into this metaphorical insulin door, opens the metaphorical lock, and lets sugar into the cell. That's an agonist. An antagonist in pharmacy world literally has the word blocker in it. So antagonist blocks something. So if you picture a piece of Scotch tape going over the lock, something like a beta blocker stops adrenaline or epinephrine from getting into that lock and doing that thing. So that'll stop things like your heart rate going up if adrenaline surges. So is that pretty good for antagonist?
That's good, yep.
Okay, and partial agonist, quit smoking drug, varenicline or Champix, it partially stimulates the nicotine receptor so people have less cravings, but it also partially blocks it so nicotine itself doesn't go in there if someone smoked while they're on varenicline. So that's like a partial agonist.
Yeah, partially activating, partially turning that lock.
Okay, good. Now, that is kind of where my pharmacy school ended. I agonist, antagonist, partial. Now we're going into a whole bunch of other things that we're going to need help with. So, all the stuff we've been talking about so far is hitting the orthostatic site, like the actual where the normal ligand or the normal key fits into. So that kind of sort of makes sense. What's an allosteric site?
Yeah, so allosteric, literally translated, allo just means other in Greek. So it's just an other site. So if we use the lock and key mechanism analogy, you've got your receptor is kind of like the whole door. And in addition to maybe a spot for your main key that's going to unlock your door, you've got separate keyholes that can fit separate keys. But they might change how fast or how slow the door opens, or they might change how wide that door can physically open from fully open to fully closed. So it's all about fine tuning and modulating the signal of the receptor rather than a simple open closed or on off mechanism.
Okay. Now, because we're going to mention this a lot in the paper, negative allosteric modulator. So this is the side of the key, the lock. We're gonna take this metaphor till it breaks.
Sure. Yeah.
And if I stick the key in there, so in this case it's CBD, it negatively affects how something like THC does its thing if it goes in the main keyhole lock?
Yeah, so if we're looking at the paper we're talking about specifically, what we're suggesting is that CBD, it is binding somewhere else on the receptor, interacting with some other part of that door to effectively reduce the ability of CP55940 or SR141716A, which is an antagonist we use in the paper. Something binding the orthosteric pocket. CBD is going to effectively limit the ability of that main compound to bind to the receptor. It makes that main key site a worse fit for the key.
Okay, and we don't talk about it much, but just so we cover it here, there's a positive allosteric modulator.
Yeah, so the flip side of that would be, you're binding some other site on the receptor, some other place on the door, and you're making that main site more permissive or a better place. So you're effectively augmenting or turning up the activity of that main site. You're not directly activating or inactivating the receptor. You're just making it a better or a worse environment for that main drug. Okay,
and two more that just, I didn't know what they meant, but they were in the paper, so we'll throw them into this pile of things at the beginning, and then we'll really get into the paper. An inverse agonist or antagonist and a neutral antagonist. What are those?
Right. So typically, when we're taught biochemistry initially, we usually think about a receptor being on or off. But frankly, that's too simple. All receptors are kind of always a little bit on. I'm going to change our analogy a little bit, and I'm going to think about dimmer switches in your house. Okay. So if you have a light switch in your house, that light switch can be on or off, but the dimmer switch can go from dark to, medium bright to fully bright. The receptors in our body, they're always a little bit bright, they're always a little bit on, a little bit functioning. And an inverse agonist is going to take that little bit of brightness away and turn it all the way to black. So an inverse agonist is cutting out all of the baseline. A competitive or a neutral antagonist is just going to block the receptor. Going back to your earlier analogy of the tape over the lock, the neutral antagonist is just going to block that receptor from being activated.
Okay. All right. I think we've got enough definitions to start jumping into the paper. So you and your team have been working on how CBD affects the CB1 receptor for a while, and you've been specifically looking at where it binds, and with the, well, A, we just want to know, but B, one of the things down the road is if we can find out how CBD binds and does its thing, then maybe we can make drugs that will also do that. So let's talk about, you had some potential candidates for where this negative allosteric modulating site, this NAM site might be, and where did you go with that with the paper?
Yeah, so in the paper, we looked at a few different sites. There are known synthetic negative allosteric modulators, or NAMs, of CB1. And we wanted to compare those to some newer putative sites on the receptor. So there's not just one allosteric site. There are probably many. You can think of, I'm going to just keep throwing different analogies out at us.
Sure, yeah.
But I've also described a receptor recently as a pair of cargo pants. And, your cargo pants have hundreds of pockets on them.
Okay.
Your receptors, they have lots of pockets, lots of places for things to bind. And what we wanted to do here was see if we could pin down which pocket might be interacting with CBD. The way we did that was through a technique called site-directed mutagenesis. This is a molecular technique. Effectively, you're just going in and you're swapping out amino acids in the receptor to change the goodness of fit in each of those pockets. And then you can see how the drug's binding changes.
And you guys are capable of just going down and literally changing out one amino acid?
Yeah, well, I mean, to be frank, we contracted that out to another company.
Sure.
It is a possible technology, yes.
Okay.
We went ahead and we did that, and we were able to identify, okay, here is a putative pocket on the It's actually the same part of the receptor on the side outside of the receptor that is thought to interact with cholesterol in a normal environment. That seems to be where this synthetic NAM ORG compound binds. And then we were able to identify a separate pocket kind of inside and underneath the receptor where it seems most likely that CBD is interacting.
No, I'm going to jump in with two things that I read in the paper that confused/interested me. First is, why is cholesterol binding to anything on a CB1 receptor? Do we know? Do we care? It just does. So that was my first thought, is what's cholesterol doing there?
Yeah. So cholesterol is in all of our cells. It's a critical part of the cell membrane. And almost all membrane-bound receptors, or receptors that live in the membrane of our cells, have cholesterol binding motifs that are just part of normal function. We think it helps them kind of stay anchored within the cell membrane so that they can kind of be in that lipid environment.
Okay. And the other, probably not going to come up, but just as a pharmacist, I thought it was interesting. Fenofibrate, the cholesterol drug, is also a NAM?
Yeah, there's been a couple of reports from one or two labs that have described fenofibrate as being a NAM within that same kind of site, which makes sense structurally. It's pretty similar in terms of its structure, but that's not work we've done personally. So,
okay, so you've identified some sites. You use some fancy computer models to say here's where they should possibly be, and now you're picking apart different amino acids to see what happens. So what was happening?
So effectively what we saw was that CBD seems to bind to a different and unique site from where we think that the other compounds like ORG or ORG bind to. So this means that we have a unique putative site that we can now go in and kind of our future work, our future goal is to be to interrogate that site a little bit more and figure out what I would call a structure-activity relationship. So effectively, what are the requirements of the drug that would make it an even better binder to that specific site that we've identified? And can we hone in on specific components of the molecule that would make it really good at being specifically bound up in that site?
Okay. No, that is very cool. Now, again, we don't know because the theoretical new drug hasn't been found yet, but I know some of the things that have come up with THC versus some synthetic cannabinoids is something I didn't realize. Apparently THC is actually more of a partial agonist than a full agonist, and when we put in a full synthetic THC-like agonist into the CB1 receptor, not always good things happen. So if you find an even quote unquote better fit than CBD into the NAM site, I guess we'll have to do further testing to see what that actually does.
Yeah, absolutely. Further testing will be required. The classic line, more research needed. However, the nice thing here is that we're not targeting that orthosteric site. And because we're not targeting that site where THC or other synthetic cannabinoids were binding, we're not directly activating the receptor. And so we believe that it's very unlikely that we'll see intoxicating effects. We're not directly activating the receptor, so it's unlikely that we'll see the negative effects associated with some of those synthetic or spice cannabinoids.
Okay. So, and we might jump back to the paper, but we're going to go a little farther afield because it's come up in a couple of our previous interviews. So, all the cannabinoids are big fatty molecules, which, sometimes that makes it easier to transport them around, sometimes not. But they also seem to all have, or like THC and CBD for sure, have both their acidic and we'll call it neutral configurations. So one of the things that was discussed was in the plant. So like if you took the plant orally or if you didn't heat it up before taking it, you should get more acidic version of the cannabinoids like CBD into your body, and that acidic cannabinoid might affect its receptors differently. Is that a thing? Do we know if that's a thing? What can you tell us about that?
Yeah, so really what we're doing here is we're asking the question, is THCA or CBDA worse than or better than THCA and CBD, excuse me, THC and CBD, right? We've done a little bit of work on this, both in cell culture and in mice. And some other colleagues in the US, mostly Jenny Wiley's group in the US, have done a little bit of testing on this. And in general, what we see is that if we think of THC as a partial agonist, then THCA is an even worse, even more partial agonist. If we were to put percentages on it, let's say, just to use numbers as an example, if THC activates CB1 by 50%, maybe THCA activates CB1 by like 25 or 10%. So just less good at doing its job.
Okay.
CBDA seems to be a bit more complicated. CBD as a non-acid compound has what I would call a promiscuous pharmacology. It binds to a lot of different things.
Yeah, we've heard like up to 40 or possibly more different receptors it hits.
Yeah, absolutely. And the same seems to be true for CBDA. So it's really hard to pin down, what does CBDA do? But certainly THCA seems to just be a worse version of its non-acidic counterpart.
Okay. No, that's good. Now, and if you don't know, that's fine. But Kirk and I were discussing, and the answer was, I have no idea. So somewhere between ingesting whether the acidic or the neutral cannabinoid and getting to a receptor, your body moves it around a lot, metabolizes it a lot. By the time it gets to the receptor, is it going back and forth between acidic and neutral? Is it that in the body? Is it? We've heard that there might be more acidic cannabinoid in the body anyway because it's more we call hydrophilic, goes through water better than the neutral, which will sort of have to be latched onto something else to get that fat blob through. Do we know anything about whether in the body it's more often neutral or more often acidic, or is that kind of up for debate?
I think that's up for debate. I think it's just simply a matter of we don't have the data to know for sure. It's only been in the last 3 or 4 years that, tools like standard compounds to do mass spec work have been available for the acid versions. So that makes knowing or answering those types of questions pretty difficult.
Okay. Thank you. I think you've cleared up that little thing that Kirk and I have been working on. Let's go back to the paper. So other than, trying to develop something like CBD or works like CBD at the NAM site, what else are you kind of hoping will come out of the, what you've identified here? Anything else sort of on the list of that's cool, we should take this information and run somewhere else with it?
Yeah, so I think the first thing in this space that myself and our collaborators at University of Mississippi are interested in is really identifying and improving on the structure-activity relationship, getting new drugs. And I think the reason that we're interested in that is, like I said, CBD is a promiscuous molecule. So we've identified a hit here where CBD seems to bind to this one site, but all of that work is computer-based or in cell culture. So it's like an artificial model system. In a living organism, CBD has all these different effects at these different receptors. But if we could make a molecule that was more specific to that site, maybe we'd have something useful, right? So that's kind of the direction we're going with that. Okay. Beyond that, though, one of the things that we're really interested in is, we've identified a couple of allosteric sites now on the receptor. And one of them that I mentioned already was this cholesterol binding site. And that, to be fair, wasn't originally identified by us. It was identified by other authors that did a crystal structure study. And we used their model in our paper. But that interaction site where cholesterol binds, that's in the membrane. And a big question in the field right now is, do receptors themselves, do they interact with their signaling partners just as a single receptor hanging out, or do they actually buddy up or partner with other receptors in that cell?
Okay.
And could that buddying up, what we call heterodimerization, could that buddying up actually change signaling? So if you have a serotonin receptor and a cannabinoid receptor, do they physically interact at those interfaces like the cholesterol binding site? And does that affect their signaling? So I think long term that might be another direction that we take some of this work.
Oh, that's very cool. I'd never heard of that nor thought of it, that the receptors might physically interact with each other, and very cool. But that would also make things, as usual with cannabis, way more complicated. If you both have, like you said, a CB1 receptor and a serotonin receptor firing or misfiring, or one fires, one doesn't, in a coordinated fashion, interesting things could happen. Yeah.
I think a lot of our understanding of a lot of these ideas comes from textbooks, and in a textbook you tend to see this one little receptor hanging out in isolation, just doing its thing, but that's not how cells really work. That's not the environment that is really existing in the models that we're studying, right?
Well, that was interesting. I really enjoyed it, and really you took a very complicated paper. We'll have it posted so people can read through it themselves. But I struggled during the reading because pharmacist, not a biochemist, not a pharmacologist. That hurt my brain a little bit, but it's good to mentally stretch a bit. That was really good. You've answered sort of all of our questions. Anything else you think that the listeners should know about your paper, or anything else sort of CBD related?
Yeah, I think there's a lot of interesting stuff going on in the field right now, not just with CBD, but with other allosteric modulators. I think it's a great opportunity to kind of stretch or change how we work with these receptors. And I'm hopeful that, we can develop really good, useful therapeutics using this allosteric approach that avoid, some of those negative side effects that we associate with cannabis, whether that's the high or, some of the abuse liability concerns, anything like that. This might be a real avenue forward that sidesteps some of those issues.
All right, Kirk, I won't claim to have the depth of knowledge of Dr. Laprairie, but anything about that you want me to try to answer?
Well, no, I think you started, it was interesting how you started your interview with him. You started it with a thesaurus or a glossary, definition of terms.
A bunch of definitions.
And I thought that was good. Interesting, though, I always thought a PAM was something different. Now I see a PAM as a different acronym.
PAMs and NAMs are different things. Yeah, in pharmacy world, a PAM is still a benzodiazepine. But yeah, NAMs and PAMs, and that's why we have to be careful with acronyms. They change as you move from context to context. But one of the things I just, as a bit of pharmacy trivia, so fenofibrate is just a run-of-the-mill cholesterol pill, and it sort of tweaks my interest about the fact it acts as a NAM. It's sort of the same kind of way as CBD, so makes me wonder, if we give more people fenofibrate, does it have some of the same effects as CBD? Now that's stretching things a whole bunch, but I got a kick out of the fact that a run-of-the-mill cholesterol pill has some of a similar effect to CBD at the CB1 receptor.
Fair enough. I said at the start of this that my goal was to apply this to practice, and what I kind of liked about the talk in this episode is that when you start thinking about people that are using new vape pens and that have formulations of high THC, basically these vape don't have the whole flower in them. Somebody has produced a cannabis vape to have a lot of THC in it and some flavors. And what I got out of this was essentially that THC, high amounts of THC can cause anxieties and can cause tachycardia and paranoia, and a lot of people that have difficulties with cannabis will often say that they have those side effects. Well, with a CBD added to it, acting as a NAM, right, you can decrease the effect that THC has on the CB1 receptor. So CBD doesn't necessarily go into the same lock and key, but someplace on the cell, CBD grabs onto that cell and dampens the effect of THC. So from a practice perspective, this is an example of if someone comes into the emergency department with a a green out effect, maybe in the future medicine will just take a suck of this high CBD vape, and maybe that might knock the THC off the CB1 receptor and act as an antagonist and dull down your anxieties. Would that be a way of applying this in practice?
That is possible, and we have talked to, not necessarily in greenouts, but we've talked to clinicians in the past who have, especially on cannabis hyperemesis syndrome, and they've done things like hot showers. Now, honestly, I'm sure there is a mechanism for why a hot shower should work, but I don't quite get it. And things like, I believe it was the beta-caryophyllene and things like black pepper, for treating the cannabis hyperemesis syndrome. But I haven't actually heard of any, but I'm not saying it shouldn't work, but I think we should try first. But yes, I agree that sounds like if you gave someone CBD, you might get less paranoid from too much THC. Parts that I thought were interesting, kind of adjacent to this paper, is I didn't realize THC wasn't a full CB1 agonist. And why that matters, sort of along the lines of what you were saying, is some of the synthetic cannabinoids, the spice type ones, are full agonists, and that might be one of the reasons why they seem to cause so much more problem than actual THC, which is kind of a partial agonist. And also made me think, and I might be stretching the analogies a little too far, but if you put a NAM in there, like a CBD, to modulate it, well, if the THC was already sort of a partial agonist, is that what allows it to, like Dr. Laprairie said, move the dimmer switch up and down a little bit, is because it wasn't sort of a hard and fast and rigid key in there. Now I'm mixing my metaphors, but I hope you get the idea. And the other one that, as we've talked about on other episodes, was the difference between acidic and non-acidic cannabinoids. Now, this isn't the full thing, but it was one of these. Well, of course, we've talked before about how you don't get high off of acidic THC. THCA doesn't make you high. And Dr. Laprairie talked about that a little bit. Now, he says, I'm not using real numbers, but let's have pretend numbers. Let's say the THC, activates the CB1 receptor 75%, and THCA only activates at 25%. So having that extra tail, that extra acid thing in there, makes THCA not make you high. So that clinically we can agree with. But it also, back to some of our things earlier about, the medicinal effects of the acidic versus the neutral form, kind of makes sense because, it'll affect the receptor differently because it's literally a different shape. And I don't know, I thought that was explained well. It sort of made me think about it differently, that, of course, we already have this obvious example of the psychoactive effects of THC versus THCA.
Yeah, that's real dense stuff. You made a comment earlier just about how hot showers work. My understanding how a hot shower works in a green out effect, if you've greened out, is that you have CB1 and CB2 receptors in the skin, so the hot water will rebalance the overstimulated cannabinoid receptors in your skin. There's also a component, the psychological distraction. So, when you are greening out, you're overstimulated on the paranoia and the freak out of being greening out, that a hot shower might distract that. Also, it improves the circulation to your skin, nervous system, and it helps your body regulate your your thermal regulations, because the endocannabinoid system is very much involved with thermal regulation. So that's some of the reasons why a hot shower happens. Just trivia. Not sure what.
Yeah, no, and others, and I don't take this as gospel, but I've also read about the TRPV1 receptor, which is interesting because it sort of kind of has to do with your body's sensation of heat, which is sort of kind of related to how capsaicin, the active ingredient hot peppers, works as a painkiller, which sort of also has to do with how the cannabinoids work as painkillers. So I again, don't take this as gospel, but my rudimentary understanding is that also, when you actually activate these TRPV1 receptors with a hot shower, it does some cascading things in the endocannabinoid system too. But again, that's Trevor's very rudimentary understanding, which is not to be taken as gospel. And honestly, I would love to have some smart person explain that to me better.
Well, this is another one of Trevor's chemistry-based ones. I like it from the perspective of clinical practice, in the sense of truly understanding that there is some true science behind cannabis. And another reason why we started this passion project was to bring those kind of things forward. And hopefully there are people who are in clinical practice listening to this episode, because I think it is important that we understand that this kind of research is going to go into big pharma, right? Big pharma is going to want this kind of research to create the next, hopefully not synthetic, but natural drug that comes from the cannabis plant.
No, absolutely, and just the overall understanding of whether you're a whole plant or whether you're pull out a drug and manipulate it person. Either way, understanding how the actual receptors and the endocannabinoid system work is going to help with the whole overall understanding of how we help people with cannabis and cannabinoids.
Yeah, cannabis is medicine. Yeah, no, it was a good one. I don't really have much more to say. I found it a very interesting conversation. I appreciated the vocabulary lesson. I had to go back and read about it a little bit and see the words. The way I learn, I need to see words. Hearing them is good, but I need to see them also. It helps me learn. So yeah, I came away with a little bit of knowledge, and I came away with a little bit of knowledge that really does explain more how CBD works with THC, so they work hand in hand. It'd be interesting to see if how the other cannabinoids work in this regard.
Oh, absolutely, and it was a back to school moment for me. I really liked it. I hope everyone followed along. But yeah, in pharmacy school, it was agonists turn the receptor on, antagonists block it, and partial agonists are kind of half turn them on, and that's kind of the end of pharmacy school. I was even quizzing one of our smart new pharmacists, and she thought she might have heard of an allosteric something or other. But yeah, even the smart new ones, this is not sort of common how we think of in pharmacy school anyway. I'm sure the PhDs think more about this, but in common pharmacy school lingo, this is not something we think of. So, got to stretch my pharmacy brain a little bit too, it was fun. I really enjoyed it.
Yeah.
I'm Trevor Schufelt. Yeah. I'm the pharmacist.
I'm Kirk Nyquist. I'm the registered nurse, and we are Reefer Medness, the podcast found at reefermed.ca. We're on most of your socials there. LinkedIn and Instagram and Facebook are the ones I seem to focus on. That's another good one.
All right, thanks, guys. It's Renee here back in the studio. That was a little bit heavy, I must admit. I'll just give my head a shake. There. A couple things to clean up before we go here. We like to mention that here at Reefer Medness, the podcast, we acknowledge that we produce our shows on Treaty 2 territory and homeland of the Métis, and we pay our respects to the First Nations and Métis ancestors of this land as we reaffirm our relationships. We're going to end with a song here that was requested by Robert. He says he generally listens to punk and metal, but he thought he'd go a different route and picked an instrumental song that he usually has on as background noise when he's working. It's part of Cass's theme by Game Chops, and here we go.
Check out the complete library of Reefer Madness episodes at reefermed.ca. And make sure to follow us on all the socials for bonus info on what Trevor and Kirk are up to.
I'm going to stop here. I have paused. I've frozen. Am I frozen at your end?
Yes, you have.
Okay. Well,
you were frozen. You were frozen. I can still hear you, but you have stopped moving.